In this video, we learn how to solve maximum likelihood estimation on Word using mathematical typing. This is a topic of CS1. Let's start with this question. A random sample of size n is taken from a Poisson mu distribution. Derive the maximum likelihood estimate of mu. So first we'll write the likelihood function. The likelihood function is L, which we write, and then I insert a alt equal to write my equation, put a bracket, backslash of mu and a space. This will convert it to mu. Then I continue writing equal to, and then I'll write backslash prod. The prod function will give me the product sign after writing space. Then I need the limits I equal to 1 to n. So you write underscore because you need that in subscript. I put a bracket and write I equal to 1, and in the power you need n and press space. See, it has converted to pi of I equal to 1 to n. And then you now need to write your equation, which is e to the power minus mu to the power xi divided by xi factorial, which is the function of distribution function of Poisson distribution. So let's write e to the power, and then I need to write minus backslash mu and a space and another and close bracket and another space. So it has converted to power, and then again backslash mu to the power. So see, it has converted, and now I need xi. So x underscore I for a subscript and space. See, it has come divided by, which is a slash sign, space. It comes to this factor sign, and then you can come to this box and write x underscore I, which will give me xi, and then a factorial sign, which is an exclamation mark. Okay, simple. Now we'll write the next line. So let's come out of the equation using right arrow keys, and I'll come down, press tab, I'll write equal to, and then in equal to I write my first is a constant, and then into I write my equation after breaking this. So constant into, you can also use a direct alt equal to and write inside this c into will give you, so see, this looks like an x, so use this into sign from here. Okay, c into, then e to the power minus e to the power minus n and backslash mu, space, close, space. Okay, and then again I need mu to the power summation xi. So I give a space, backslash mu, space to the power, I open a bracket, I write backslash of sum, which will give me the summation sign when I press space, and x underscore I. Again a bracket, again a space, bracket close, and space. So see, this is as easy as this. Just need to remember, with practice this will come on. Okay, and now I come to the next line. Okay, when I come to the next line, now what I need to do, I need to take log on both sides. So I write taking log on both sides. Okay, so taking log on both sides. Now what we'll write ln, which is this function ln, and you can copy this from here. Okay, this log likelihood function. You can obviously adjust the font size for all the values together. So just let me adjust the font size because it has changed. Just keep it to 20 currently, very visible. Ln of mu, and then I'll insert my equation. My equation is c, which is the constant, minus n into mu. So I'll write n backslash mu, that gives me n mu, plus summation of xi. So backslash sum x underscore I. Okay, and then I'll write ln mu again. So this gives me the log likelihood, and then I take a differentiation on both sides. I'll write alt equal to, I write d, and I'll just copy, I'll write d by, put a space, and this comes d backslash mu. So d by d mu, and I'll copy this entire thing because I'm taking a differentiation of this value. Okay, I'll don't waste time, and let equal to, and for constant it's 0, for mu it will be minus n, plus for this value it will be summation of xi. So I'll just copy summation of xi instead of writing it again and again. You can copy it directly. So copy and then divided by space. See, this comes up and this is mu. So you get this equation. Okay, you can see this, and then if you see it's the orientation, just give a space. Okay, it will come, the orientation will come, and now we have to set this to 0. So setting this to 0, you get this equation, that mu hat. Now how will you write mu hat? Again, alt equal to, I'll write, see, I'll go to this accent, and in this value is my hat. Okay, and I'll just write divided by mu. Okay, this gives you mu hat is equal to, now see, you have to come out of your highlighted area, otherwise this hat will go on. So mu hat equal to, now if you had equated this to 0, we know this will be equal to summation of xi divided by n. So divided by sum x underscore I and whole divided by n. So this gives me the value of mu hat, and I'll paste the space so that this comes in line. Okay, and now I'll check for the second derivation to check the maximum condition. To check for maximum, double derivation you do. I'll copy this. I'll show you all. It's very easy. So copy and then write. So I'll just copy this. I'll put a square, d mu square it will become. So this has become, and above also just put a power sign and square. So d square d mu, on one step it is done, and then equal to, and I need a summation minus, and then I'll just copy this again, this part which is already there from your first, which is summation xi by, and this becomes, instead of n, this will become mu square. Okay, and since this is a minus sign, so since this is less than 0, hence maximum. Okay, so this is very easy on when you do this. Okay, so this was your maximum likelihood estimation from CS1.